you have my slide?
It's all upgraded, updated.
Okay,
Yeah. Oh.
Yeah.
No.
How we shape the whole thing.
No, no problem. Wow. Like it's how many minutes you're talking about? Okay. Okay. Sure. Then have to change. So the here, right? Rakesh cannot make it. Okay, so client facing like this one?
Yeah, and it is.
How do you call that?
It's draft. The code IRK.
Yeah, okay.
HOLZ.
Don't you remember?
Just one O.
The big red button.
Minus
And then
then basically you can do the like an individual.
Okay.
Yeah, it's Google. It's not a tracker. I think it's a version of or.
But I don't have your slide, so
Yeah, I am slides.
this one. This
No,
one.
I have no slides.
Oh, it's on top. Okay, okay, okay. And I just realized I don't have the proper adapter for this.
Oh. Yeah, this is almost good phone.
Does anybody? Yeah. Does anybody have a connector? We don't have. I don't have connector for this. I have a small one. Yeah, small little one.
Yeah. I guess
I should have one.
anyone with that.
Yeah, I should remember to carry it.
So I would. Yeah.
Thank you so much. Thank you so much. Yes, they will work. They will work. Yeah, it works, huh?
Right, we're just settling ourselves down here and learning how to use computers. We'll go in very few seconds.
You got what you need?
What is that?
Have you got what you need?
Yes, I got everything. And it's 1 o'clock exactly.
Oh, very well.
Shall we start? Okay, good afternoon. And this is I2NSF session. And here we are Adrian Farrell and myself, Linda Dunbar. And it's 1 o'clock already. And thanks very much to Frank and Sue Harris for volunteering to taking the minutes. Thank you very, very much. And we'll start. So first of all, note well, and hopefully everybody has read this. And remember that everything you said is public information. And some of the administrative charter, and we have a mailing list. I hope everybody is aware of that. and we have minute taker. Okay, and here we are, and agenda is being posted. We have slides, and we have, here are the agenda version. Any problem, any question, any objection? If not, we go forward. So here are the milestones we have achieved, our use case and problem statement. I already finished the last call into the IESG's hand. And we have terminology and framework, which are ready for last call. And next one is we already adopted a client-facing interface requirement. And we have decided to move problem statement forward as to be published for IFC. But the gap analysis, I think we dropped that, right? And we're going to move forward the information model for the capability, and also later on we'll move on the data model. The future milestone, okay. We need to adopt the information model, and we'll look at this client-facing requirement. We need to look into make sure they are complete, and we'll adopt the data model a little afterwards. Once make sure they are consistent. We have several data model drafts. We want to make sure that they are consistent with each other and consistent with the information model being described in the capability draft. And for the applicability statements, we don't have any contribution on this area. If we still don't see any contribution, maybe we'll drop this from the working group charter.
So maybe you can give us a heads up. Is there anybody here who thinks they want to work on an applicability statement, describe how I2NSF could be used in particular environments? Okay, so I don't see anybody saying they want to, but I see Diego getting up to volunteer to do all the work for the whole working group.
No way, but no, seriously, not that I will be in the position of volunteering for that. By the way, I'm Diego Lopez, Telefonica. But I think my impression is that there are some documents already proposed. This one's proposed by Paul Young and these others that they were about this IPsec SDN control. That could be, I mean, could be seen as initial applicability statements. And this is something I would ask you precisely to contact the authors.
Okay, thank you. So the second question was going to be who actually believes applicability statements would be useful? Sorry to hijack.
Hi, John Strassner, Huawei. Regarding the first one, I'm happy to help on an applicability statement, but I'm kind of overloaded on IDs, so I don't want to be the sole author. Second question, I believe that an applicability statement is useful, but it's hard to write so that it isn't 100 pages. So it might be good to brainstorm on the list what the contents of such an ID would be.
Thank you very much. And we'll have more discussion on the mailing list on this then. Okay, and future milestone regarding to the IANA registry. This is really register all the capabilities of network security functions. I think they were ready to do that after the capability draft being mature and being adopted working group draft. And Here are some of the early drafts to IESG for publication, the problem statement and use cases and terminologies. I think after this meeting should be mature enough, and framework. And we're going to shelve the gap analysis. And data model and the applicability statement, the IESG, for publication in the future. And then afterwards, we're going to either close or recharter, depending on the workload. And here are some reminder. Make sure remember those wiki pages and issue trackers. And with that, let's move on to the first presenter, which is the terminology, the working group draft. Oh, what happened? Hey, what happened? Doesn't show this. Oh yeah. Why is that showing the? Oh wow. See? Extended? No. Okay. Duplicate. Oh, okay. Yeah.
Hi, everyone. I'm awake now. I'm John Strassner, and I'm presenting on behalf of the co-authors for the terminology draft. Click. So this slide summarizes the changes from the last version to the current version. In terms of areas, Hank and I sat down and we further aligned with SACM. We think that it's important for SACM and I2NSF to go forward together. There was a fairly major rewrite to the terminology draft, motivated by a kind request from our co-chairs, to reduce duplication. So we might have had policy and then policy role and then I2NSF policy role and yada, yada, yada. Now there's just one I2NSF policy role definition. In a couple of places, we didn't follow that model, but that is why you see a long list of items under refined existing terms. We added some new terms. And this is also aimed at ensuring that we can talk intelligently and still at an abstract level about different consumers and producers of a policy role. And then we did some miscellaneous changes. I'm trying to go fast, so click. This is directly versus indirectly consumable policy rules. I personally am not happy with the name, especially since I came up with it, but I think it's okay for right now. The idea is simply whether a policy rule, when it is sent to a network device, needs translation facilities or not. If it doesn't, it's directly consumable. If it does, then it isn't. Click. So next steps. We think we need to explore the subject of attestation more, and we can talk about that later in today's program. Metadata. The use in NetMod is not really aligned with the use of metadata in other SDOs, so we need to have a discussion as to the importance of that and whether we care. Similarly, there's some confusion about events and whether events can occur individually or they must be streamed, and what exactly does publish and subscribe really mean? And once we do that, and also explore what I believe is a slight mismatch between the info model and data model drafts, where I think terminology can play a role, we should be ready for last call. And that should be it. Oh, and at the end, in case people were wondering about different types of policy rules, you have 3 slides from a tutorial I did that talk about different types of policy rules. I would like to emphasize that currently we only care about imperative or event condition action policy rules. And you can stop there, Linda.
Okay.
So the chairs would also like to see this last call soon, because that way the framework can go forward and everything's got a stable base. The small set of issues you've got there, could you start a thread for a separate thread for each one on the mailing list?
We could indeed.
And then we can find out if people care and we can nail them down quickly and move on. That'd be cool. Thank you.
Sure.
Thank you.
Am I done?
Yeah.
Yay. Oh, any questions from the audience? I don't know why I'm encouraging that. Okay.
Okay, next one's the framework.
Now, this should be completely straightforward, so I will just go for the next one. The two, these ones are the same I've been using in the past. Is about how we started, and the next one, please. It was how it is represented on the document, because we had to use ASCII art. So basically, it's the same. Just to illustrate, the first one is, and well. Now, the only thing that I can see that is still an open issue is that whether we should use the term developer and vendor is something that we had to align a little bit, because in some places I was very insistent on using developer rather than vendor, just to address the idea of open source software, etc. I don't know if anyone has a good idea of something that is neutral enough not to be understood as either a commercial relationship or something that allows for considering open source. Is simply that, not no more than that. We need to go through the whole document to be sure that we are fully aligned with terminology. But in both cases, the alignment should be straightforward. Finding a term would be highly appreciated if you have anything in mind that is better than developer and or vendor. And apart from that, I think we're ready for the working group last call. The only thing is that right now the document is supposed to be informational. If you're talking about the framework that is going to be a reference of the rest of the world, maybe we should not make it informational. It's something that, I mean, it's just, again, it's not a big issue, frankly. So that's it.
So to be clear on that, Diego, that would be a one-word change at the top of the document. It wouldn't affect the content. Okay, we can let our superiors work that one out.
Perfect. I can live with that. Happily live with that. Good.
No questions, and I think next one is the hackathon report.
Okay, hello everyone. This is Paul. Yesterday, we presented I2NSF hackathon. Next slide, please. So this time, the difference from last IETF 98 in Seoul meeting. So we used open source for the file filter for Srikata. So my plan is we plug in the open source code. This time we plug in firewall. Next time we implement the DPI, deep packet inspection. Next, we consider attack mitigation using open source code. Also, we planning to use the OpenStack. So this time, the overall result is pretty much the same as the last IETF Seoul meeting. Next slide, please. So overall architecture is the similar. The major difference is that the firewall, the NSF is replaced with the real open source Suricata. That is a major change. Next slide, please. So remotely, the SKKU Songyungan University, my students participate in remotely this time. So we show the pictures. Next slide, please. So skip, yeah, the concept of NSF, you are familiar with it, right? So next slide, please. So the goal is, I mentioned the firewall for the open source using the Suricata. This time, Suricata is, as you know, is open source for IDS and IPS, but we can modify for firewall. Next time, we can using Suricata for DPI, deep packet inspection. So next slide, please. So also we proved the I2NSF framework works well with the open sources, and also we validated the I2NSF interface design in terms of the consumer-facing interface and NSF-facing interface. Next slide, please. So this shows the open source code environment. Okay, next slide, please. The scenario of this time, this is a time-dependent firewall, which means employee. This is, imagine you are employee, so you cannot access the Facebook during your work time, such as 9 a.m. through the 6 p.m. You can block. After or before your work time, you can access Facebook and YouTube and website. So time-dependent. The firewall is enforced by I2NSF security controller. Next slide, please. So this is also the other difference is previously we used the last API for I2NSF consumer-facing interface. This time we used the last comp, and also we used the Suricata for firewall. So next slide, please. So we uploaded our open source into the GitHub. So this is open. Also, we have the documentation. You can freely access this website, and also you can give some feedback. So we try to improve our I2NSF open source. Also, the Huawei engineer labs are also implemented our I2NSF framework using the Snort. So we try to converge, in near future. Okay, that's it. Yeah. So any questions or comments? Okay. Okay. Good.
No, it's precisely what I was saying before, that it looks very much as the initial step for an applicability statement. There is a clear use case. You're using I2NSF. Is a practical, well, probably to have, as John said, I hope you would not need the 100 or 200 pages that John was suggesting, but anyway, it's something that I think we have here a clear case, and would be really interesting that we move in that direction.
Mm-hmm. So, I believe our I2NSF is based on the NSF. The NSF network virtualized function based on that. So also SDN still you can see nowadays SDN NFV technologies merge together. So still I believe SDN network will be useful for. So my group is working for the I2NSF based on SDN network. Okay, so in the future also we try to using SDN NFV together. Okay, thank you. Yeah.
Thank you very much. And next one is Rakesh. Is he on the? Oh,
Yeah. Well, it's another meeting. I think it's a remote presentation. That's why it's so loud.
okay. Is he on the line? No.
Rakesh, can you hear us? Can you go to Meet Echo and ask to speak?
So just give a little background on this. There is a open network user group, primarily consists of many enterprises. And this year, at the beginning of the year, they form a new working group called Software Defined Security Services. Rakesh is the chair for that working group. And they basically primarily working on the requirement for software-defined security services, and they have agreed that they're going to use the I2NSF working group's data model as the basis. They're not going to work on the data model or information model, but they would like to provide a requirement and maybe provide input to us. And they also they would like to hear what we have defined and give comments to the work. So he cannot talk. Rakesh? Oh, yes.
Yeah, so Rakesh is talking with Meet Echo in Java to try to sort it out. We'll skip and come back later. Oh, whereupon Rakesh turns up. If he can talk, I think. I guess I have to press the red button.
Can you hear me or no?
Rakesh.
Yeah.
Yeah, we can now hear you, Rakesh. We can
Sorry, I
even.
did not know. This is the first time I'm using this. So,
Yeah, we're just getting your slides up. So off you go.
okay, thank you very much. Thank you, Linda. I apologize for the technical difficulties. So like Linda said, that there is an open network user group, which is started by IT executive I think 4 or 5 years ago. And the reason they started was they want to make sure that a lot of times the solutions, what they have, that they want to have their own perspective and the problem and the use cases they wanted the development community and the vendor community to work on that. I have put the link there in this slide. And it was started by Nick Lipes and others in the IT executive industry. And it is, as I said, primarily user-driven community, and it has multiple groups. So one of the group which I started working on this year, like Linda said, was software-defined security group. So this group was there, I think they started last year, and they already have done some framework, what the requirement are, and they have published the white paper. I put a link to that white paper, and that white paper links requirement from the user perspective. What are the challenging problems they see in the security industry? And chairs are me, Fred Lima, Scott Bedner, and Lipes. Can you go to the next slide? Yeah. So the proposed work is that we build user requirements, what user really wanted to do. When I say user, I mean what the IT industry want, security issues, and what they think those use cases are, which are important to them. And then the next thing we want to do is, once we understand those user requirement in details, we want to update the software-defined security white paper with the detailed user requirement and the architecture framework for development guidelines. So the vendor community can propose work based on those requirements and the framework. So next thing is we want to make sure that this work is really can be used by the user as well as vendor community. We want to publish data model, the API. And I'm trying to make IETF and the I2NSF working with as a vehicle to model these requirements. And we want to encourage the open source effort, just like Mr. Paul was presenting that. I think it would be good that there is an open source group or the developers which take this framework and the architecture document and propose some work. and we want to encourage vendors so that they can participate in this work and propose solution. And based on this data model published by IETF and I2S, we can measure their complying to the user requirements. Can we go to the next slide? Thank you. So one of the targeted, or the few of the targeted use case which they already have identified is one of the most important thing: apply and bind policies to the workload. So what they mean is, as the workloads are moving between the hybrid cloud, private cloud, and public cloud, they want to make sure that policy, once applied to a workload, it stays with the workload no matter where the workload is. Although this policy might change based on the location of the workload. And the second use case, very important, is a portable security policy. What that means is the user community want to express this security policy in a way that if they change the security solution from one vendor to another vendor, they don't have to change their security policies. Or let's say if they want to build their security fabric, which is a policy enforcement point in the network, and whether they change from one vendor to another vendor, or they take security functions from, let's say, by doing the service chain, they don't want to change the security policies. So the goal here is security policies should be portable. They should be independent of the vendor, independent of the technology which is implemented this security policy. So like I said earlier, this working group has defined this use cases at the very top level. And the next thing what we want to do is go into the more granular details so that we can see the work we have done in the IETF, I2NSF, whether that meets the requirement or those requirements are not good enough. So can we go to the next slide, Linda? Yep. So these are the architecture goal for whatever this ONUG working group would publish. Protect against vendor and technology lock-in. I mean, this is fundamental to the use case they identify that the security policy should be portable, and they should be able to build their security policy informants or the security fabric from any vendor, any technology as they wish. And the policy has to be consistently enforced. Like I said, that if the workload is moving from private cloud to public cloud, or if the workload in legacy data center, if a policy applied to workload, it stays with the workload. So these are the main tenet of this this architecture goal, or the framework which CSS want to do. And having said that, one of the ancillary requirement which is automatically needed is that users should be able to build their security policy using any network element, routers, switches, firewall, or these they could have network ACLs embedded into hypervisor-based switches or virtual switches, SDN controller, or if the workload is hosted in the public cloud, whatever that infrastructure is provided from the security perspective in those public clouds. Can we move to the next slide? Yep. So this is the architecture framework what we have worked on, which is very similar to what we have defined in the I2NSF. Basically, there's a controller which really gives us the northbound interface, user interface, or the client interface, or whatever terminology we agree, consumer interface. And that will meet the requirement of the security policy would be portable. If the security policy is implemented, let's say using one vendor solution, and for whatever reason, a user want to go do a different vendor, or they want to use a, let's say, container-based security instead of they want to put the security policy in the switch, those policies should not change. So that is the fundamental tenet of this. And the second thing is we want to implement those security function interface so that a user or a bank or any enterprise should be able to build their security fabric or the policy enforcement point by using any technology from any vendor. Like we could take firewall from like Huawei, Juniper, Palo Alto, or whoever provides that. And the policy enforcement should be everywhere. Like I said earlier, that if the workload is moving from, let's say, private cloud to public cloud, and the public cloud have certain way of implementing those security policies, we should be able to take advantage of whatever the native mechanism to implement the security policy. So pretty much this aligns very well with the I2NSF and the work we are doing. Only thing is maybe terminology may be a little bit different because this group wants to make sure that a secure fabric or the security fabric which would be used for policy enforcement can be embedded in the workload if desired, like container-based, or let's say workload has a mechanism to implement a security policy, or we should be able to use security policy framework in the networking elements like routers, switches, firewall. So other than that, I think it looks very, very similar to what we have in I2NSF. So I think this is pretty much what I have. And I would work with this group to make sure that the consumer-facing interface, what we have done is it aligns or at least it meets their use case requirements. So Linda, I think that's pretty much from me. Thank you very much.
Thanks, Rakesh. And it's obviously really helpful to us that you're there and you've got a foot in both camps and can see. Please shout to the chairs if you think that the chairs should be communicating anything formally, but I think the informal channels are probably going to work just fine.
So Adrian, I think Linda is participating. I think Linda can speak for that. She joins every other week the call. Linda, you want to say something?
Yes, actually, the work is consistent, and I think next step is bring our information model to there to be reviewed. The participant in that group really want to see what IETF has defined, and they want to see if there's something they can actually use. So, thank you.
Thank you very much.
Any questions for this? Okay, if no question, we're moving on to the next one, the capability by John.
Okay, this is the capabilities draft, which was merged from two completely different yet very similar drafts. So click. A capability is the ability for an NSF to provide a function. It could be a vendor-specific function. It could be a vendor-independent function. The capability will be registered through a dedicated registration interface. It's a way to abstract with well-defined semantics what different NSFs are capable of so that you can achieve a broader interoperability for your application-specific security needs. This draft, we've defined not just some exemplary NSF capabilities, but actually defined a formal algebra that includes how capabilities are constructed, and with a goal of ensuring that the hardest problem, which is conflict detection and resolution, can be solved. Click. This is just the history of it. Click. So this is the overview of the model that we've got. Up on the top, we're assuming that you could have a generic source for not just the policy portion, but also metadata. This is important because a capability is actually best defined as a type of metadata, because it isn't something that is important to the inherent definition of an object. Rather, it is some extract or some very specific view of the features that this object provides. So what we've done is built a model to be as generic as possible so that you could use as wide a range of models as you want. That being said, one possibility is obviously the IETF SUPA model. The SUPA model not only defines an information model and a Yang data model for policy rules, but also for metadata. So if you go down to the bottom half of this figure, what you see in this draft is a specific set of event condition action policy rules that aggregate different types of building blocks. SUPA has a wide range of them. Right now, we've chosen just to start with events, conditions, and actions. So from an object-oriented perspective, you might have a generic event object. It may have a payload. It may have semantics that says whether it's a request response or just a notification or blah, blah, blah. And then we take that generic event object, subclass it to build security-specific events. And those are tools that the policy rule can use to express things that it must enforce. The metadata or the capabilities fall into three basic categories. So generic security functions available from the network, and then content and attack mitigation specific capabilities. Click. So this is a English description of the first half, or the policy rule portion. An event is a significant occurrence that an NSF is able to react to. A condition is basically a truth statement, at least in this form of the policy rule. If this set of conditions is satisfied, then the NSF may use the following capabilities as part of its actions. And then, of course, the actions are the fun part. There's some additional things required to specify semantics, not just metadata, but probably the most important part is resolution strategy. So, for example, simple example, John gets gold service, FTP gets bronze service. What happens when John sends FTP? Well, if it was me, probably segfault. But that would be bad for the working group, right? So the resolution strategy is a formal mathematical mechanism to figure out what all the possible actions are of this policy rule if the event and conditions are matched, and then choose one that doesn't conflict with other policy rules that are running in the system. Click. So this is the capability algebra. There's 5 basic terms: the set of events, conditions, and actions, the resolution strategy, and the default action. The first 3 are simple. If I've got 2 policy rules and I want to combine them to build a more robust third policy rule, as you would expect, you would take the union of all of the set of events and conditions and actions. That doesn't work for resolution strategies and default actions. Resolution strategies in general are going to be specific to a rule. And so I can't take the union of them because I could have 2 resolution strategies that conflict with each other. Default actions are also a problem because trying to build as broad a model as possible, and thanks to operator input here, this has helped. We have 3 basic choices: no default action, a single default action, or here's a set of possible default actions, pick one. So you can't take the union of null, 1, and n, right? Because it's got different semantics. And so what you end up with is an asymmetric operation that we've carefully specified. And what we've done is a set of simplifying assumptions in the algebra so that, in essence, the first resolution, the first policy's resolution strategy and default action is considered the base that you add additional policies onto. So we take the first default action and the first resolution strategy from the first policy, or leftmost if you want to think algebraically, and then all the other ones, we ignore those 2 terms and just add the set of events, conditions, and actions. Click. Oh, we have a question.
I'm sorry, I don't want to get up from the scribing. The question is, this is interesting algebra. Are you going to provide simple examples to make it easy?
Sure. So the original paper, which is the part from Diego and Cataldo and a couple other people, I'm brain farting, so I apologize on the authors, had this done for the condition action case. There's a very elegant paper that goes through some of those. And then when we fit this to ECA, of course, you have to add events. And then when we added events, we said, well, gee, we want to make this a little bit more flexible. And so Aldo and I in particular are working on yet another paper, YAP, to document this in a more formal mathematical language, and then we'll take, once that's done, we'll take excerpts from that and add it into the next version of the draft. Other questions? Cool, click. So as we were reworking this draft, and those of you that have read it will notice that there was a huge difference in that we moved all of those really exciting object definitions and attribute definitions to appendices. So that cut down on about 50 pages on the draft. Yay, team. And as we were doing that, we said, well, what else would make this perfect? So, and these are all documented in the draft within asterisk, whatever. Sections with asterisks, there we go. So for example, the event and condition clauses, if you look at the policy academic literature, and there's significant literature there, are typically represented in conjunctive or disjunctive normal form. Translated into English, that's and of ors or of ands. And would that be useful for us? This isn't for us to decide, this is for you, the working group, to decide. Hint, hint. Event and condition clause evaluation functions, right now we've kept it simple. Boolean clauses, so I can say if the source IP address is in this range and the destination IP is in this range, and not the source port from this range and blah, 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 as long as it's a simple Boolean expression, it can be as many terms as you want. Of course, in real life, sometimes Boolean expressions don't cut it. So question to the working group, do we need more? Same thing for the action clause evaluation. So the two simplest ones are, if I have a number of possible actions, I just take the first one, that's good enough. Or I take the last one, that's good enough. Or maybe I do something more sophisticated. I run every action until I get a failure. And then, of course, you have the question, well, what do I do in the failure? Do I roll back just that action? Do I roll back all the actions? And so this is actually a very interesting question that hopefully the working group will respond to on the mail list. Another hint. We can add more on metadata. So for example, do we want to simplify the resolution strategy by including the notion of priority? That gives you at least a partial ordering to the set of rules. And then right now we have asymmetric operations. Should we simplify it further to symmetric operations? Do we need other things, etc.? Click. And so what we're really trying to do is make sure that as we prove that this works, we can go back to, as Sue prompted, simple use cases with documented examples. And oh, by the way, if you really are paranoid, well then here is the algebra that is needed to prove that these use cases work. which leads to a final question, and this is the biggie. If you look at the draft right now, we've made it as simple as possible. So we have used inheritance, i.e. subclassing, to introduce new functions. That is great, except where it isn't. And where it isn't great is if you've got a dynamically changing environment where the rules have to be constructed at runtime and you don't want to recompile and redeploy and blah, blah, blah. In which case this model would have a couple problems. And so there are established ways to fix this, but this increases the reading complexity and understanding of the model. So one last question to the working group: what do you want us to do? And that's it.
Thank you.
Questions? Going once, going twice.
Okay, so this is a
Ask a question.
you can get up. It's all right.
Adrian. No, it's a remark when coming to the two options. Thinking about what Sue was asking about examples, my only remark would be that the second option would be much better in terms of model-driven, and probably that it would require something that we show by example, and probably I was thinking whether we could try to make something connected to some open source environment like Open Daylight. And it was just a suggestion that came to my mind.
So that is a great suggestion, actually, Diego. We have already in SUPA engineered ASCII-E's for showing not just UML, but object diagrams. So remember, the big thing here is what happens at runtime, how many objects do you have, how are they connected, blah, blah, blah. So we could actually do this as an ASCII draft.
So yeah, so this is clearly a working group item, charter item, and the working group's previously shown desire to work on it. So it's great that two author teams have come together. Question for the room: who's read this document?
Not surprisingly.
Yeah, sorry. So I'm seeing about half a dozen hands, which is not a lot. Does anybody at the moment object to adopting this? I guess it would have only been those 6. So we'll go to the mailing list. Now would be a really good time for people to read this so that when we have the adoption poll, we know what we're talking about.
Thanks.
Thank you. So the next one is the remote attestation. Diego.
Okay, so this is the first version, well, the second version actually, because I made a few changes before coming here. Next one, please. Basically, the idea, if you remember, all is about how you clients can be sure that the environment in which things are running are trustworthy. The platform is, and which is something that brings me to the problem that we have the platform definition. You can trust where you're running the functions, you can trust the functions themselves, and you can trust that the configurations that you are requesting are properly applied. And in the I2NSF architecture, the proposal is precisely to do it through the security control. Or when it comes to the traffic, through an endpoint that has been designated by it and can be attested as well. So the idea is that the security controller makes the measurements available to the clients can make a decision on them, and rely on by its own, by the client itself, or relying on a trusted third party. Here there are some ideas on some results that can be used that are not included in the document yet. Next one. So from the latest version, again, this is something that was said when we met well, we didn't, I was remotely participating in Seoul, which is about the virtualization focus has ceased to be. Originally, this was part of well, it was connected to the virtual network functions, but the idea is that you can use it in any case. So right now, even then in the name of the document, the title was changed already, and any reference to virtualization has been deleted only in the cases in which special considerations are made for virtualization environment it is maintained. It has been updated according to the received feedback, most from John, in fact, and including the alignment with the common terminology. As far as I know, it's fully aligned. It's it has a better description of whatever is going to be subject to attestation, though we still have a problem that I mean, in the document, you're using I2NSF platform once and again, and we are not using, we have not defined platform in the technology, I mean, in the terminology, sorry. So it's something that, the question is whether we should bring it to the terminology since it's only being used here. So this is,
Oh, and John, just for everybody, could people say who they are?
Everybody. I am John from Huawei, and I actually think that these terms should be included in the terminology document. There's going to be more work on attestation, and TCG concepts are hard, and I don't propose that we copy that, but if we're going to start using TCG-based concepts, and if we try and do a union of those with non-TCG, we better have terminology or we'll get lost.
Yeah, this is Hank Burkholz, Fraunhofer. Yeah, there are more SDOs than the IETF that somehow use the term attestation. And we at the IETF think have the opportunity to bind those definitions together, make them interoperable, provide terminology that will leverage or enable interoperability so that they can figure this. Also, we can extend our set of terminology to existing solutions that can be used as complements to attestations, or vice versa, where attestation is a complement to existing solutions. And we already started with that a little bit. And also, now this is specific to the TCG, I think. Their terminology is kind of old. They have an official set of glossary, they call it. And it's the only document that is basically directly available on their front page. So, but it is old, and it would not be a big surprise if they would update it in the near future. So I think this should also have to be taken into account, that the terminology that other SDOs use at the moment might not be as fixed as it looks like.
okay, so basically, 1 second. No, it's simply there are other terms that are very much focused on this and that I don't think should be to the terminology, but basically the commands precisely what the static and continuous attestation is, the definition of a bootkit that appear out of the blue in the middle of the document, or what the trust channel is. But anyway, this is something that is very much specific to the attestation. So the way forward, first is asking the group whether the group believes that this is a work that is worth continuing. I hope so. Looking at what Hank was saying, I hope that it's even more. And then the idea would be start working. This is a list of the particular issues that when writing the document I have in mind. First is the defining different level of assurance. So you can define, make it as so the client can specify requirements about the level of assurance that it wants to apply from the security controller. So you had certain different degrees and you had choices. And when it comes to this, second is something that it was, well, first introduced in Berlin, and still I see it open, is about using anonymous attestation, because that makes sense. In my view, that makes sense if we're going to attest the client, not when it comes to attest the functions. And this is something that we have to, that would introduce some kind of asymmetric behavior. That's, I mean, I don't have any objection about that. I remember that there was some concerns that Rakesh and Anil, it was, yeah, and Anil were making about requesting full mutual authentication, and I wanted to, this is something that's, it's open there, we have to discuss it, to elaborate it, and go a little bit further, and we'll go for the particular protocols. So far, it's only about the general framework, and we should, well, explore things like what has been done in NIA some time ago, SACMAN, or TCG itself. And well, there is this tip-off. I was asking Hank before the meeting that sounded a little bit connected to this, and probably we should try to somehow align with them, even leverage whatever they plan to do, or even contribute one way or another. So these are the things that I think we should address if there is interest, that I do believe will be the case. And that's all, I guess. So,
Any questions? If not, Hank has some other thing you want to talk about the attestation. So you want to talk a little bit, 5 minutes? You want to talk about it? Do you have a slide?
Yeah, hi, Hank Brockhaus again. Now at the mic. Fixing the mic. Yeah. Yeah, so it's a short presentation. The method Diego uses in his attestation approach is the typical one. Attestation is including the activity of proving freshness, which is kind of simple. If you create a nonce, send it to the verifier, it can send it back to you, or actually even it can be created by the verifier and sent back by the attestee, it doesn't matter actually. So freshness can be proven by a nonce. And we created a draft that is called the time-based unidirectional attestation, which eliminates this challenge response interaction between the attestee and the verifier by adding a third party that provides all other parties, essentially the attestee and the verifier, with trusted time, which is kind of a very established and old concept. It's a 12-year-old RC, I think. Click. So this time-based unidirectional attestation is basically addressing the same problem space. The input and the outcome is the same. It adds another component to the architecture, which could be at the I2NSF controller, for example. But it has a few objectives that can go beyond attestation. So it is intended to increase confidence in the interaction between the components. Of course, you now have more confidence about the thing you attest about, which is in general could be called an object integrity authentication. The draft we provide uses very small amount of data. It's a very concise representation with CBOR. It also does not have this freshness problem with this nonce. So if you do not create the messages with every interaction, you can store the attestations for a while until still they're deemed fresh in regard to the timestamp token authority. So you do not have to recalculate everything all the time. You do not have to resend everything all the time. So it is reducing load on constrained resources, which can be in a TAE, which can be in a hub security model, which can all be bottlenecks, and also, of course, the network. It is built to facilitate components that cannot retain state over time. So it is for rest. Can be used with SNMP. can be used as a beacon in HO2.1p with talking a car to a traffic light, just beacon out its attestations. And of course, it can be used in scenarios where you have a temporary loss of connectivity between the attest and the verifier. Again, both somehow have to have a trusted timestamp to function. That has still to be. But you can therefore attest past states of the attestee, which is interesting also again for constrained nodes that might not be always connected. And as a side product, because you can attest past states here, you essentially create secure audit logs of your attestee that are, if not conveyed to a verifier, are stored at the attestee on the function side of the attestee. And that can be very interesting if you would want secure audit logs anyways, which is a little bit independent of the contribution of attestation here. In this case, it is a side product, but a subset of the protocol would create secure audit logs that is in itself a contribution, I think. So this is just my introduction of this approach of attestation, which complements Diego's draft, which elaborates on a lot of details we do not elaborate on, especially of how to extending PCRs, for example, which can be complicated to understand. So thank you for that. And yeah, this basically concludes my 5 minutes. I think. Thank you.
Thank you very much. Any questions for Hank? Okay, thank you. So we move on to the next one.
So as Paul's coming up, it wouldn't be I2NSF if we weren't running behind schedule. So everybody should keep an eye on time and move things along.
Oh, yeah. So this is a Paul again from SKKU in Korea. So this document explains the corresponding consumer-facing interface aligned with the Rakesh consumer-facing interface information model. Next slide, please. So next slide. So this document describes information model and the data model for the security management, especially the VoIP LTE. This time, we are planning to accommodate the more information models such as the firewall and authentication next time. This time, we just focus on VoIP LTE, one of the DPI application. Next slide, please. Okay. So this is I2NSF client giving the high-level policy using the consumer-facing interface. So security controller translate into low-level policy and enforce low-level policy into NSF. Next slide, please. So this is the architecture of the security management. So overall architecture is based on I2NSF framework. We try to decompose, such as application logic, generate the high-level security policy. That policy into delivered to a policy updater. So policy updater is delivered to security management system. And then security policy manager receiving that policy translate into the low-level policy with the information stored into NSF capability manager. Capability information is from developers management system using the legislation interface. And then that low-level policy generated eventually and delivered to NSF instance using NSF basic interface. Next slide, please. So some event happened. So recently, the prank, he revised the draft about the NSF-based interface monitoring information model. So some event or alarm or some log message generated by NSF, and then that information delivered to NSF-facing interface. Eventually, security controller can generate a high-level event or alarm or log information using some aggregation or some modify something for high-level information. That information delivered to event controller, and that event controller delivered to the application loads eventually, and then we can generate or some modify our high-level policy. That is the story about the security management. Next slide, please. So this security management, we focus on the VoIP LTE service. Okay, so we have an information model for this VoIP LTE. Next slide, please. So next, so the update is we include the new component for feedback. It is called the event or alarm log. So I think that is aligned with the Plank draft for monitoring NSF facing interface. Also, we collected corresponding data model. Next slide, please. So the major thing is the rest box update list indicate the NSF feedback or unexpected event. So we can specify this event information. Next slide, please. So the update policy, eventually this policy will be the client point of view policy based on the event triggered by NSF. Next slide, please. So the next step is we try to expand our data young model, including the other network security model and content security and attack mitigation models. So we also will align with the surpass the data model. Also, we implement for more use cases, okay, such as the untrusted domain or access control function depending on time and location. Okay, so which means we try to implement the content security and attack mitigation also. Okay, okay, that's it. Yeah. Any questions or comments? Okay, thank you. Yeah.
Thank you. The next one is
A remark. Well, while Sue is preparing, this is Diego again. Yesterday I had a conversation with Benoit Claes on his concern about the community keeping the publication of young models using documents rather than publishing it using the repository and tools that are more connected to software development in general. I mean, it's a general comment. It's something that I don't know.
Okay, can I respond with a couple questions to clarify that? My understanding is your question is whether the models are in the RFCs. My understanding is Benoit is pulling those models from the RFCs and validating them. The same mechanism, my understanding was, I may be incorrect, that this same mechanism, he eventually was going to plug them into a repository. Is that right, Eric? Was that what I understood?
Yeah.
Yes, so we didn't put them in a repository already because we thought Benoit was going to do that for an IETF wide. Is that okay? I mean,
Yeah, no,
if it needs to be sooner, I'm sure that Paul and I and all the rest of my co-authors could put him up in advance, but it just sounded like it was going to be any day now. Do you have any further? Nope, we don't know. I can ask Benoit when he's going to do it, because if you want it up in a data model, I think they've got it in their
Okay.
In their build process, it's not a big deal to do.
Perfect.
To
No,
put it up in a GitHub, I can create an I2NSF repository, or Paul can, with his students and just put it up there, and while we wait for Benoit. Now you know why we didn't
yeah,
rush
no,
to do it, because it was
it
supposed to
goes-
be any day.
I know it was simply noting that, well, his point was precisely about these documents, once they get published, we're going to be less dynamically updated than a repository with a model. Simply that.
Okay. The idea that Benoit had mentioned was that this single repository would contain all IETF models and might contain the IEEE models that we were depending on. So it seemed like a much better idea at that point. Okay. Did that make sense to the chairs?
Both yes and no. I'm grateful for the two of you for having this conversation
Okay.
and not including me in it.
Okay. Fine. And if you would go ahead. So again, in interest of time, I will simply note that Paul has covered this scenario about security controllers and where the capability model in the previous slide. Does anybody want me to repeat Paul's explanation? Okay, Paul did a wonderful job doing that. Go ahead, next. I'm just going to focus on what's changed. You do have a time crunch, right? Okay. Again, notice the capability that Paul described is what is being passed in both in our logic and in the experiments he did with the hackathon. So this is not just fiction. This is, test code he's published, where you're actually using the NSF forwarder that might be a security box that would be forwarding either internally out another interface. So all of this should match what you think we've been doing, and the capabilities are saying what sort of security mechanism we're doing. Okay, now on to the real world, or our world, which is maybe not the real world. This is an updated version from 00. It matches what Paul has implemented. I'm going to talk about the draft, and then I'm going to talk about what we did do and what we didn't do and how we learned. That may be verbal, so listen as well as watch. Go ahead. So first of all, the natural thing to do is to update the types of IP addresses. We better be doing IPv4 and IPv6. Then we went from the last draft and we enhanced the type of security filters. There's some filters which are specifically DNS. There are some in FTP, games, RPC. Now this targets more the concept of what are we doing from an application. This is different than our initial attack, or by initial attack, which was to take on a very protocol basis. But this may be much better way to actually group it from a user level. Go ahead. And also from capabilities. Remember, the capabilities sit on top of what's actually functioning in the security. So you see in the first one, the IPv4 address, v6, no big deal. Okay, next one. Now you see where we've actually done the support and then the link list of the filters and the various things that work. This is a mechanism you saw in our previous work, and pretty much, again, a capability model where you say, does it exist? And then you give a list of functions. Okay, and you may have underneath that a vendor name or standards. Easy. So that's basically the change. Now, put on your ears, and what was different than some of the original models is we went to this functional base. What is it doing for the user as opposed to these are the PDUs and packets and bytes we're doing? Because in the end, that capability is very Greek, or very excuse me, my apologies to anyone who's Greek. I'm teaching ancient Greek, so I use that adage. It is not modern Greek that I'm speaking about. That was a little oops. So it's really hard for the user to think in these abstract terms and put something useful together, as opposed to the various filters. So we've switched away. You will see as you go deeper in the draft, you may see various filters for layer 3 or layer 4, but we've again gone to simple. The idea is, how do we get experience with what we're doing? We can go from the routing side and from the security model side and say, these are the things we've always done, and encode them. Our experience is that may be difficult. I'm looking for some feedback, and I think Eric is popping up to give me that very good thing.
So I guess I got to give some now. I like what's happened from some previous drafts in that there were a lot of attempts to remodel existing things that are now summaries. You know, this is the outputs instead of actually conflicting with Yang models being developed in other places.
Yes.
And that's a good thing. Is there going to be any attempt in these abstractions to talk about the types of model bindings or other relationships which might exist to those other items, or are they going to be decoupled with the relationship between the models kept to the implementers?
Okay, let me ask a question of the chairs, and because I'd like to know if I would like to answer this. Just, do you want me to take time to do this here? Okay, so let me answer that. I just had to ask them, do you want me to add? So right now, I hope we will do that. The barriers to entry in reforming this is many models are not refactored. Refactored I define as the following. Refactored is really, how do you break things down to the component part? A lot of the models, even I've seen in T's, are not yet refactored. The base model is refactored, but as people add on, they repeat things. And as Eric and Paul and various were experiencing, that's not really useful. You know, use somebody else's model or do that. That's a process of model work. So I'm hoping, because it'll be more effective for the model writers to do that. What I need to ask, and why I asked the chairs to give me this moment, is if you're a security vendor, rather than some of us who are doing these open source push projects that are solving a point problem or an open thing, is this what you want? You know, and again, I would ask, this would be a question to the list, because we really do need to have input on, you know, how much do we make these things align with other IETF models? Do we need to instead be looser so that the vendors can do their thing? And that was a whole part of this setup, is that we don't want to tie this so tight, the vendor to IETF models, that the vendors can't do what they need. And so if you're from a company and you need to go back, please go back and think about that and then come back.
I think you articulated that nicely, Sue. And I wonder if you could actually ask that specifically on the list.
You think, okay, I would be glad to.
Just a general opinion on that. I think that it was good to get away and abstract away from the other models. Implementation guidance that says, you know, there might not be a specific mapping or binding to the other models, but a look to these locations for the data that might be linked. So you have an unofficial listing of related information might be a good way of not making an explicit or enforced.
That's true. And so I will attempt, Eric, to write this up on the list after I stop taking notes, and then maybe you can correct me. But anybody else in the room sensitive, who's a security vendor in the room? Okay. Okay, security vendors in the room really want to have feedback, because this is one of the base models as a capability. You know, we don't want to tie it tight so you can't do your business. We want to tie it tight enough so that things aren't disjunct and you have a lot of extra code to put in. Okay, I thank you for your time.
Thank you. Next one is the monitoring. Is that right? Oh, Hank, right?
Hi, this is Hank, presenting the information model for monitoring draft and progress on that. And so this is just a recap. You might recognize this slide from last IETF. So there's some question already answered on here. There is not decided yet on if we produce Yang modules, do we still have to need an information model? That's a good question we will come to today. And also, what do people think of the content of the draft? There was no big pushback. That's good. I have to highlight again, maybe not everybody was there last time, that the draft includes a lot of real-world information element that is relevant to the security monitoring process. So this is from actual vendors coming. It's not only one vendor, but at least two vendors. And it is of high value to understand what is important to this specific group of peers. Next slide, please. So, but what is the purpose of monitoring here? In the draft, it is mentioned that is ultimately supposed to help and enable humans to remediate and intervene if something bad happens, something that is considered unsecure. So that's the purpose of the security function, probably. So in order to do that, we have to understand what we have to monitor. So there is this raw list of information elements. That's also understood and in there. So this may be of interest for whatever happens. And there's this new Yang event notification draft that explicitly mentions the creation of events from Yang models. So this is one way we could leverage actual publication of events. But why go I'm down that road if I'm talking about an information model here? Because they exclude explicitly the semantics of event streams. They talk about publication and events, and this kind of means there are a lot of events that come out of that, but still no event stream. So why is that? Because event streams carry their own semantics. You can publish a raw IP address all over, and it has no meaning, but if you put it in a specific stream, so if you have a function around that provides semantics to the stream, this might be the addresses you just saw on a specific interface on a specific device. So it's a very specific semantic to that stream, and now that's the question already.
As an author of that draft, I'm glad you guys care about it. If there's anything else you want, let us know over in NetConf. We did explicitly leave out the semantics of defining the streams for reasons just like you're talking about.
Yeah.
If you think you need something else, let us know.
Yeah, of course. There has to be some complement, and it is okay to leave that out because that knob that transfers semantics from the payload, which could be enriched with all that information, and then is humongous, and not just in a MAC address, or to the state and the function that established this stream, which then carries the semantic, is a thing to be decided and to be, I don't know, problem specific maybe. It has to be dynamic probably. It is one of the knobs Sue is so fond about. And so it was one of those knobs that could be actually automated in the process. Hi, John.
Here it is. So I've only briefly read the two NetConf drafts, but I'm worried about what is expressed in NetConf. It doesn't match common ESBs that I'm using or even simpler message brokers. And so I need to read this in more detail, but I'm happy to do so and to give you more specific feedback on your approach.
Thank you very much. I think there has to be a set of components here. One of them is the event notification in Yang. And of course, there is the existing function set and architecture of NFS. And
Yeah, I didn't say my name before, Eric Boyd. If you have any questions or want to talk about this, we are thinking about going to working group last call very shortly. So please send in comments on those event drafts.
Okay. So again, I'm not worried about not having event streams there. They can be covered in another place. So again, talking about events next slide. I'll just skip the rest. Next slide in the interest of time. So yeah, updates on the draft itself. We incorporated the current terminology. Mostly, it's a hard thing to change words in a big draft. So I think it has been done quite thoroughly, but I don't think it's complete. So we will continue doing that. Also, we have an interesting problem to solve, which is the classification of data. So we have all the information elements, which you typically lack. And now we have to somehow make structured use of them by categorizing them, maybe in a hierarchy or something. And so, first of all, we think this classification is useful, but I have to ask, do people think this classification of events is useful? I mean, beyond the semantics you put into the actual, for example, stream, and because there is an ongoing activity in the ID event mail list that, and they actually, all of them agree that a security event is intended to be used to represent an assertion already. So that actually would somehow exceed our definition of event. And that's interesting because there's another side of scope. I heard voices coming from SECOM that basically, and I quote, the selection of meaning like an alert is something that violates a policy, an alarm that is something that has an impact on operation, is an arbitrary definition that has no meaning at all. So this is in direct contrast to other parties that are working on security events. So this is an actual discussion. We have to start a discussion and we have to do it across work groups, I'm afraid. So John again.
John again from Huawei. So I've managed networks in excess of 20 years, and good old X731 from the ITUT a long time ago thought that alarms were kind of interesting. And I mean, I'm kind of shocked to hear that, right? They've always been really interesting. And there's this little paradigm called event-driven programming, right? And the whole purpose of that is to categorize which events are semantically important so that you don't have alarm storms and all those wonderful things that us network managers do. So, no, please.
Yeah.
And we need the...
Yeah, but we might have to align with other work groups and have to bring the discussion to them.
Which is fine, but if we're going to go with the 90s and get into event-driven programming, then we need events with semantics.
Yeah, in general, I would totally agree. But again, we have to be interoperable with other solutions. Yeah.
I mean, just as a reflection, anyway, maybe we're talking about completely different things. I mean, when we're talking about the policies that we're managing and the events we're considering for our policies, we're talking about any kind of events. I mean, something, whatever can happen. Whether that translates into something that is going to be a security event, because a security event, in my understanding, when you're talking about these other groups, when you're talking about security events, it's something that has been identified as related to a threat.
Yeah.
Here, we are talking about, in general, flow-related events, whatever they are, because we are specifying the behavior or controlling the behavior of the security functions. And security functions, as in general, the kind of security functions I understand we are dealing here are not only dealing with threats. They're dealing with prevention, and they're dealing with installation of certain behavior to preserve security, not to react. In those cases are more reactive.
Yeah, okay, agreed. The reactive part is maybe has too strong a focus on existing terminology, and that is correct. Also, the overwhelming amount of events is maybe due to the alarm, what's it called? Alarm management framework, MIP. It's very old, but it defines event as, and I'm not kidding, something that happens that is of interest.
Well,
so I'm going from that, and that's an actual standard, proposed standard, sorry. There's a misalignment there. So the security event is an insertion already. That's a filter, somehow a subset of all events. And we have to make it, we have to be very carefully how to express this demarcation line.
Yes, yeah, no, that's true. That's true.
And that's I think that is the problem other workgroups could have with our approach. If we totally diverge from their concept of having this demarcation line, then there might be friction. So we have to consolidate a solution that might satisfy most consumers here. I think.
John, Diego, everybody, I sense this is a topic that wants discussion. I also sense that it's already 1:30. So moving on. So do have the discussion, use the mailing list and the corridors.
Okay. Yeah. On the list, please, everybody. And next slide. Yeah, it's a controversial proposal, so we just established that. And it's vital. We also had all that. Next slide, please. Yeah, final question. Logs and events are differentiated at the moment because they are, I don't know, traditionally handled differently. Logs are just created and retained, and events are emitted proactively. But in the end, semantically, they are somehow the same. It doesn't matter if you emit them or if you choose to store them in a loosely defined format that you have to take a lot of effort in to get events out of them again. So semantically, logs and events might be very closely related. And defining that in the information model would help, not just to create another category, but just say, yeah, these are basically a list of retained events. You have to handle them with more effort. The end, literally. I don't know if this is the solution, but this could be one approach to solve this. I just wanted to bring this to attention. That's my last slide.
John again. Well, you can have a log of events, but it's kind of hard to have events of logs. In other words, yeah, you can, when you're writing a log, you generally can include additional contextual information that it's hard to include to the raw event unless you annotate that event by some mechanism. And so I would assert that they're different.
Okay.
But I know, to the list.
Yeah, to the list. Okay. Yeah.
Yeah, so while the next person comes up, please. Sue said that I2RS takes a separability of they're two different things. Next slide and speaker, please. I'm completely lost because you're taking stuff out of order.
Hello, everyone. It's Frank Xia from Huawei. This draft is a 00 new draft, and we want to propose a useful but very simple feature to the current I2NSF policy model. We call it policy object, so it's very easy to understand. Let's see next slides. Next slide. Okay. Firstly, currently we in our I2NSF policy model definition, we just we use the ECA model, event, condition, and action. And for our condition part, we use a lot of attributes to match and to determine what we to do, what our NSF should do to the flow, to the everything on the network. Okay, but these are all the very individual attributes. But currently, we think that something is a combination of several objects or several attributes. We call it objects. So I think everyone can understand it very clearly. Yeah, very, very easily. So the goal of using this this thing is that it can solve some problems. By creating these objects with some special goal, and we can avoid a lot of repetitive configurations. And when we try to do the maintenance work on our policy model, it can also prevent a lot of tedious and time-consuming work. Okay, Next page. Okay, so here we define the policy model the collections of some commonly used condition attributes. So here we list some examples. So for example, one policy object can if it's an address object, so it can include a specific address, or it can be a address range or IPv6, IPv6, IPv4 address, any kinds, and yeah. And by this way, and we think that every object has his own name, individual name. It can be just the directory used by his name in any one policy. So it is reusable, and when we want to manage or want to modify our policy model, if the attributes is in some object, so we just change it or modify that object so it can apply to all the policies. So it's very quick and efficient. Okay. So currently we propose several kinds of policy objects. You can see here we list most of them: address object, address group, domain group, region, service, application, user. Yeah, that's currently we proposed. It's a very minimal set currently. Maybe in the future version, if someone think other objects is useful, we can also add, yeah, in the later version. And and then here note that the group is I think it's also very easy to understand. It means that we firstly we have some specific object, and then we can combine the same type of object into one group, just like we have a project team. Yeah, they are the group. We have a branch. They are the group. Yeah. Okay. And the next page. I think I do not want to go into too much detail about the detailed definition of each object. I think if you are interested, please go to see our draft. We have a very detailed definition of every object, and we also provide the examples for every object definition. Here you can see some example. And next page. And this is address. This is domain. Region. Region is maybe some defined by the address or defined by the geometry location, right? And the next page. And the service currently we use the transport layer or the IP layer protocol, and the destination and the source port to represent one service. Okay, we have the TCP, UDP, different kind of service. And the next page is about the application. Application here we use several attributes to define an application. Firstly, it's application category. Currently, it can be a general application, or it can be a network application, or it can be some other kind of application, right? And they have the subcategory definition. It can be a search engine, it can be an electronic commands and other kind of, and also included its transmission model and and other attributes. We try to use these attributes to describe application more correctly and comprehensively. Okay, next page. And okay, next page. Okay, this is about the user object and the user group and the security group definition. Okay, next page. Okay, next page. This is about okay. Okay, that's all about this draft current content. It's very easy, so please read it. And I have several questions. Okay, why? Several questions is So, do you think that that's country we define the policy object for the NSF facing interfaces, but we also think that it may be useful for the customer facing interfaces. So we want to get a suggestion from working group that whether it is also can be used for the customer facing interface. And oh, time is. I still have several. Yeah. And second question is, we think that actually this policy model is just one feature of the of our I2NSF security policy model. So maybe it can be it can be individual draft, or it can be incorporated to current security policy information and data model draft. So we are okay for any division. Yeah, and the third question is about we are considering currently our design is a very flat design. So it means that we do not have a hierarchy definition. We just listed all the possible objects there, and they are very flat. But maybe another way is that we can have a general object definition, and then based on this general definition, this general object, and we can inherit it and extend it to different kinds of sub objects. That's another way. That's more maybe more scalability, more flexible. So we are considering which way is better. So maybe it will reflect in next version. So if you have good suggestion, well, welcome. That's all. Yeah.
Sorry, Rakesh, I see you in the queue, but we're having to move on without questions. So mailing list, please.
So NSF page interface the Young model I quickly, just 1 minute enough. So next, just go to the change draft. Next. Yes. So we expanded this Young data model, consider the Suricata, the firewall, and the IP table firewall. So also we expanded our Young model to consider IP version 4.6 ICMP transport protocol layer. Also, we replace list data type with list data type for efficient representation. So that is, I think, the pretty much the change. If we have the interest, you can please take a look draft. Thank you.
You're an absolute hero, Paul. Right, so there are 2 slots that, yeah, do come up, Sangwon. There are two slots left. They're both you. You can split your time however you want. Okay. You've got 14.5 minutes.
Okay. Yeah. Hello, everyone. My name is Hwang Hyun from Sungkyunkwan University in South Korea. So next page, please. Yeah. So the I2NSF framework requires packet forwarding between network security functions. For instance, when a certain NSF triggers an advanced security action by another type of NSF network security function for a suspicious packet. So this traffic forwarding eventually enables composite security inspection by various types of network security functions. Next one, please. So packet forwarding between network security functions is possible with the existing service function chaining. So in SFC, basically for each incoming packet, the classifier performs initial classification, which means the classifier determines the NSF path the packet should pass through, and append the path identifier as metadata to the packet. And if the network security function path needs to be previous one, please. Yeah. So in case if the NSF path of packet needs to be changed dynamically, then that can be done through reclassification. And for the reclassification, the packet needs to revisit the classifier, and classifier updates the NSF path information in the packet. So next one, please. So this table summarizes the pros and cons of SFC for packet forwarding in I2NSF framework. SFC is good for enforcing static NSF paths in I2NSF framework. By the way, in I2NSF framework, the NSF path of a packet is dynamically constructed, not predetermined, which means each NSF makes a dynamic decision of the next NSF for the suspicious packet. So in that case, when the NSF path changes dynamically and frequently, then reclassification overhead is introduced. Next one, please. So this is our proposal to reduce the reclassification overhead. So let's assume that this packet is first forwarded to network security function 1 for some basic security inspection. And after analyzing this received packet, NSF1 determines that advanced security action by another type of NSF is required for this packet. In that case, NSF1 in our proposal, we suggest so-called capability-based packet forwarding request. So in this case, NSF1 appends the description of the security capabilities required for the advanced security action as metadata denoted as packet forwarding header, and then send the packet to the NSF forwarder. Then the NSF forwarder asks the security controller of which NSF can provide the required security capabilities. And in this step 3, the security controller replies with the information of the found NSF. And then the NSF forwarder finally forward the packet to NSF2. And in addition, the NSF forwarder caches the information of NSF2 received from the security controller in its local table for future reference. Next one, please. So in this case too, the NSF forwarder already knows that NSF2 can provide the security capabilities requested by NSF1. So in this case, NSF forwarder simply forward the packet to NSF2 without asking to the security controller. Next one, please. And to conform with SFC, we can consider this entire box of I2NSF as a single service function, which provide another packet forwarding mechanism independent of service function chaining. Next one, please. So this is the summary of our proposal. Next one, please. And this is about what we updated at this time. Next one, please. So in the future, we will clarify our trapping steering scheme under service function chaining architecture, and we will design the packet forwarding header format and also design a young data model for capability-based NSF discovery. So this is the end of the first presentation. And registration interface IM. Yeah, that one. Yeah, so the second presentation is about the information model and data model for the registration interface in I2NSF framework. So this is the summary of the motivation and next page, please. Yeah, so dynamic lifecycle management of NSF is strongly required for efficient and flexible network resource utilization. And we can do this through this registration interface, which is located between the security controller and the developer's management system. And in terms of the security, when distributed NSF exists in the system, unifying the registration of those distributed NSF with this centralized registration interface could be more secure option than individual registration by each NSF. So, we have designed the information model and data model for this registration interface for several purposes. So, with the defined information model and data model, the security controller can request the developer's management system to create or destruct an NSF instance. And also, after creating a new NSF, the developer's management system can register the created new NSF into the security controller via this registration interface. So next page, please. So this is our draft about this information model and data model. And next one, please. Next one, yeah. And in the first draft is about the information model, and we have updated the version. And in the newer version, we have added more details about the information that should be included in a request to create a new NSF. And in the second draft is about the data model, and we have designed the data model in accordance with the information model definition. Next one, please. So this is the young data model, and one thing I want to mention is we have referenced the capability data model defined in this draft to describe the capabilities required for the new NSF to be created. Next one, please. So as the next step, we will extend our hackathon implementation with 2 additional functionalities to create and register an NSF via the registration interface in OpenStack platform. So that's all. Yeah, any questions or comments?
Let me share the motivation of last 2 draft, the traffic steering draft and the registration. So during our hackathon, the traffic steering and the registration interface is required. I think currently our working group, the scope is not included this one, but we believe this one is useful. We keep working for that. Probably we charter this November. Probably there is some consensus we can work for. Yeah, this standardization. Okay.
Yeah, it's certainly something to look at in the future, and maybe also coordinate with the SFC working group, because it's clearly related there, and we don't want to tread on their toes. Okay, good, thank you. We've actually got, amazingly, 3 minutes left. So if you want to renew any of the conversations that I cut off at the mic, now is the time to do it. Or if you want to run away. Okay, nobody is excited about that opportunity. So thank you very much. There are going to be actions on the list. Several of you said you would do things, and you will be chased. Thanks to the minute takers, and goodbye.
deliberateness. It was inconsistent. But now, if you put every example of what's considered, yeah.